Hi, I'm Bill Snodgrass, and in this episode of The World Around Us, we're going to do an activity. We're going to do a demonstration of kinetic theory of matter regarding the fact that objects, as the temperature increases, kinetic energy goes up, molecules take up more space, and they expand. So this is two pieces of different kinds of metal. These two metal, and we're going to do it. So I'm going to show you how to set it up, and then we will do the experiment, and then we'll talk about it. So it'll be 3 parts, and there is a worksheet to this activity down in the description of the video. So the way this setup is very simple. You have a Bunsen burner, you have this apparatus, which you can get from scientific places there, and a tub of water. And the tub of water is simply because when we're done, we're going to put them in there so we don't burn ourselves. So that's the safety thing. Bunsen burner, lighter, it's a welding lighter thing, all lab. So gas, Bunsen burner, thing, and water. That's the setup, real simple. First thing you're going to do is you're going to light the Bunsen burner. So the way you light the Bunsen burner, you turn the gas on, hold the little thingy, make it spark, now you have fire. All right, that's the setup. We have the apparatus, we have the fire, we have the water, that's the setup. If you're doing this, that's the setup. If you're doing this in class, turn the video off, go do it. If you're still watching the video, you must not be doing it in class. You're going to do the virtual version. So go ahead and open up that lab worksheet. Get ready to go. So what you're going to do, we're going to heat this up. We can see that it passes through nice and easily. It passes right through. We're going to heat the ball up. As the heat goes up, the molecules are going to move faster. They're going to take up more space, and then something's going to happen. That will be your discussion. So here we go. I'm going to heat the ball up. All right, so the kinetic theory of matter says all matter is made of particles, and those particles are in constant motion. Anything that's in motion has kinetic energy. Kinetic energy is 1/2 times the mass times the velocity squared, 1/2 mv squared. So as the energy goes into this metal ball, probably brass, I think, it is heating up. And the molecules are moving faster, and that means that the molecules are taking up more space. And a moment ago, the ball would pass right through, and now it is much more difficult to get the ball to go through. You have to push very hard. I'll heat it up a little bit more. In the discussion section, which is going to follow this, then you're going to need to explain what happened in terms of kinetic theory. So here we go. Let's see what happens now. I cannot put the ball through. But if I heat the ring up, the ball's cooling down, the ring is heating up. The ring is heating up, and now the ball goes through. All right? Simple enough. That's how hot it was. We have 2 not hot things. Passes right through, passes right through. Guess what's going to happen? It's going to expand. The heat is going to increase the kinetic energy of the molecules, and then those molecules are going to move faster. And in moving faster, they're going to take up more space. And when they do that, it gets to the point that it will not pass through. You can get this one point where you can kind of get it through, and then heat it up more, the ball expands more, and then it won't go through anymore. It's a neat little demonstration of volumetric expansion, which is a function of the temperature. Engineering application of this is when you build very large bridges made out of metal. Very large bridges. The amount that they expand between 30 degrees Fahrenheit and 80 degrees Fahrenheit is a measurable amount. And you will see on bridges those expansion joints. Now it is too hard to get it to go through. I could heat the ring up again, or I can cool the ball off and it comes right out. That's the setup. I'll put these in here. They're nice and cool. Everything is good. Put them back down. Next group can use the apparatus. Turn the gas off. that's it for the demonstration portion. The last section of the video, we'll talk a little bit about the conclusion. All right, if you're still watching the video, you're not doing this as a virtual lab, you're not doing this, you're just watching the video. So let's talk about this just a little bit more. A lot of things we said. So the discussion question in the activity says, explain what happened in terms of the kinetic theory of matter. So in the answer that I would give is, I would go through the kinetic theory of matter. All matter is made of particles. All those particles are in constant motion. The higher the temperature, the faster the particle motion, the higher the kinetic energy, blah, blah, blah. And the faster they're moving, the more space they take up. So when you have two objects that are the same temperature, they pass through one another, no problem. As one of them gets hotter and the other one does not, then it gets to the point that this one has expanded. So you would say the sphere expanded and the cylinder stayed the same. So if the sphere gets bigger and the cylinder stays the same, you get to the point that it will not pass through. Now the tolerance on this is something down probably in the millimeter range. I didn't measure it, but it's pretty close tolerance. Applications of this concept is going to be in automobiles, in lots and lots and lots of things. But if your automobile, if the cylinder and the piston are made out of different metals, they're going to heat up at different rates. So there's going to be a problem there if the piston expands more than the engine block. That's going to be a problem. Manhole covers. If the part that goes over the manhole cover expands faster than the ring that holds the manhole cover, that manhole cover is going to expand in hot weather. It's going to get to where you can't get it off without using an awful lot of leverage and prying. So these are just two real-world examples of this principle. Bridges, as I said in the previous part, are built with expansion joints in them. So those would be some things that you could write about if you were doing this as a non-class activity. That's it for the episode. Hopefully you enjoyed this. Please click the like button, subscribe to the channel, sign up for notifications. These things are fun. You can get these in the hardware store. You can play with them all you want. A lot of fun. Thanks for watching. See you in the next episode. I was just editing the video in my head. That's why the cart went by.